This is the homework 484. Okay, so this is the coordinate proofs with slope. So looking at number one, I kind of graphed them all just to save on time a little bit. They want us to prove that it's a parallelogram. So just like what we did in our notes, we're going to find the slope of all four sides. And if opposite sides have equal slopes, then we know that they are parallel, and then therefore it's a parallelogram. Okay, so let's just kind of get right to it. So I'm going to say the slope of AD, okay, is equal to, now if you guys forgot the slope formula, it's m is equal to y2 minus y1 all over x2 minus x1. Okay, so working this out, the slope of AD, here's A, here's D, would be 2 minus 5 all over 0 minus a negative 1. So 2 minus 5 all over 0 minus a negative 1 would give you negative 3 over 1 or negative 3. So then the slope of, I guess it doesn't matter which order we start. Say I did BC. Slope of BC then would be negative 2 minus 1 all over 6 minus 5, or negative 3 over 1 or negative 3. And I picked that one just to show you guys that they would be the same and they would be parallel. So then slope of DC is 2 minus a negative 2 all over 0 minus 6. Okay, so that would give you 4 over negative 6 or negative 2/3. Again, always simplify your slope in lowest form. So then your slope of the last one we didn't do yet is AB is equal to 1 minus 5 all over 5 minus a negative 1, or negative 4 over 6, which again simplifies to be negative 2/3. So then we just have to make a statement. So we're going to say, since opposite sides have equal slopes, opposite sides are parallel, therefore it is a parallelogram. Okay, cool. And again, that would have been a 4-point question. So then going down to number 2. So it says the vertices of rectangle ABCD are A, B, and C, okay, and D. What are the coordinates of D? Now, I had A, B here, okay, and C. So how I knew D was going to go here is it's got to first off go in order. So if I have A to B to C, D has to be over here. So how I found D is, first off, this is easy because this is a straight line. This length right here, if I count it out, I have 1, 2, 3, 4, 5, 6, 7, 8. All I did from C is I counted 8 over, like 1, because I know that opposite sides of a rectangle are congruent and parallel, so it's going to have the same slope of 0. So then your answer to this is going to be the coordinate 3, negative 3, or choice 1. And we lost focus. There we go. Okay, so that's it for number 2. So then turn the page. Okay, so then for number 3. So for number 3, it says, in the coordinate plane, the vertices of triangle RST are RS and T. Cool, I graphed it already. Prove that it is a right triangle. So again, usually when they ask you to prove it, you could find all 3 slopes if you want, but using like common sense when you actually look at it, all you have to do is find the negative reciprocal slopes at one of the vertices, like where they would intersect for the lines, and then that would tell you you have a right angle. So me looking at this, it looks like there would be a right angle at S. So I'm going to find the slope of TS and then the slope of SR, and then show how they're, if it is a right triangle, well, they're telling me to prove it, so it will be, show them how these are negative reciprocal slopes. So I'm going to start with the slope of TS. Okay, that's going to be, and again, here's TS, 6 minus a negative 4 all over negative 5 minus 1. So 6 minus negative 4 all over negative 5 minus 1. And that gives you 10 all over negative 6, and that simplifies to give you negative 5/3. And you can always check it. Like if you walk and so what I always tell people is that coordinate proofs, there's a lot of ways to be sneaky and kind of get away with things. So yeah, you can kind of just visually check, like, is this going down 5, right 3? Yes, it is. Down 5, right 3. And then just kind of make sure your answer looks like it. So I've had people that it drives me nuts when, say you plug it in the formula wrong, you get the wrong slope, but you have a graph right here that you can visually check rise over run. So just make sure that you guys are doing that and that, you know what I mean, your answer makes sense with what you have. So then the slope of SR, okay, that's going to be me doing, let's see, I have negative 4 minus a negative 1 all over 1 minus 6. And that would give me negative 3 over negative 5. Negative over negative makes it positive. So that's exactly what I wanted. I have negative 5/3 and positive 3/5. So we're going to say that because we have negative reciprocal slopes, we know the lines are perpendicular. Therefore, we have right angle where they intersect, and they're intersecting at S. So there will be a right angle at S. Therefore, it is a right triangle. Okay, so we're going to say since TS and SR have negative reciprocal slopes, they are perpendicular and form a right angle at S. Okay. And then we'll say, therefore, triangle RST is a right triangle. Perfect. Okay. So that one, probably, again, 4 points. Coordinate proofs can go anywhere from 4 to 6 points typically. So it says, state the coordinates of point P such that quadrilateral RSTP would be a rectangle. So again, pay attention to letter order. It has to go RST to P. So R, S, T, P has to go up here somewhere. So we want the RS to be congruent and parallel to the TP up here. So what I can do is just kind of count my steps from S to R. So I'm going up 1, 2, 3 over 1, 2, 3, 4, 5. If I do the same count, so up 3 over 5, that's going to get me where P goes. Okay. And there you go, that would make a rectangle, okay, because these would be parallel. These would end up being negative reciprocal slopes. So your coordinate answer is going to be 0, 9. Okay, so then for this one, now this was on the exam. They did not include a graph, but you guys have to remember that you always have graph paper in the back of your exam booklet. So that's why I kind of put this on the homework, because no matter what, you always have a graph at your axis. So it says the quadrilateral has these vertices with these coordinates. So if I graph it, they're literally just asking you what quadrilateral could it be. Now, after graphing it, this is pretty obvious. In process elimination, you definitely know it's not a square or a rectangle. And to me, it's a trapezoid because I can see one pair of opposite sides parallel. And you can check that graphically if you want, because look, I'm going up 2, right 3. So this is a 2/3 slope. This I'm going up 2, right 3, up 2, right 3, you know, every single time. So this slope is also 2/3. So and these are obviously not the same slope, or else it would be, you know, a square, like maybe a rectangle, but it's not. And it's not a rhombus because obviously not all the sides are congruent. So in my opinion, this is kind of like a low ball, easy question for you guys to try. Okay, that's it for the homework. Thanks, guys.